Today I'm going to show you how to improve the airflow and convection in your offset by extending the stack. And it ain't going to cost you that much. You're going to want to watch this one. I'm sure by now most all of you have seen the Barbecue with Franklin videos on YouTube in which Aaron cooks a brisket or appears to cook a brisket on an old country barbecue pit's ranch hand. They don't make that model anymore, but it may have compelled you to buy a Pecos or a Brazos. Now in that video, Aaron does modify the cooker by simply adding an analog thermometer in a particular place, but that's it. In his book though, Aaron does tell you that there is one more very necessary mod to consider on any cheap offset you buy at a store, and that is extending the stack for better airflow. Aaron writes in his book, with any new smoker I see, the most important consideration is airflow. It is airflow that dictates how evenly, quickly, and effectively the smoker cooks. Now the fire in the firebox obviously creates heat, but the smokestack is the powerhouse when it comes to airflow. If it's the right shape and size, it is great. If it's not, it creates a problem. I'll break this down for you so you'll understand. All right, you got a fire in the firebox. Cool air is brought into the damper or door. As that fire consumes oxygen, obviously creates heat and hot air. That hot air rises and pushes the opposite direction from where the cool air is coming. That hot air travels into your cook chamber and makes its way to the exhaust. This is called natural draft. Now here's where a smokestack comes into play. Because as heat rises up a smokestack, it increases in buoyancy and speed and creates a vacuum which pulls or draws cool air in behind it. This is just due to differences in temperature, density, and pressure. Now the taller the stack, the greater the buoyancy, the faster the air travels, the greater a volume of air that is moved, and the harder the draw. This is called the stack effect. Now when correctly applied to an offset, it works in tandem with the fire to not only improve airflow across the cooker and throughout it, which results in a cleaner burning fire, but more importantly, it pulls or draws a steady continuous stream of vigorously flowing air across the cook chamber, which is convection. And you want convection, good convection, because food that cooks with convection cooks faster, more evenly, puts better bark on your brisket. Now of course your stack can be too tall. If it's too tall, you got way too much airflow coming through here. You'd be constantly trying to feed this fire to keep it going, or it might just go out. And if it's too short, or too narrow, or just too small, there'll be little to any draw. So the hot air that does come in the cook chamber just rises to the top, becomes stale and cooled off by the food that's in there, and the remainder of that heat and hot air is going back out the firebox door. And I've seen that firsthand in the Pecos. Now also in this book, Aaron does give you some guidelines if you build your own offset in your backyard, how to build the stack. He says number one, it should draft from grate level. This is so the hot air can flow over the food and right out the stack. Secondly, it should be 4 to 6 inches in diameter. Again, the Pecos and Brazos have this covered. And frankly, these two things may be a reason why Aaron chose the ranch hand. Thirdly, Aaron says the stack should be 3 to 4 feet in height. Now this thing is only 16.5 inches from the top of the elbow to the top of the stack. So certainly we are short. So what is the right height? Well, Aaron Franklin started building his own pits last year. And interestingly enough, they are roughly the same size as the Pecos and Brazos. Now they're a little larger. The firebox is 2 inches longer and the cook chamber is about 7 or 8 inches longer. They are thicker steel, obviously. The firebox is insulated. There's a collector on the opposite end. But the stack of particular interest is 42 inches in height from the top of the collector to the top of the stack. That gives you a rough idea of how tall this stack probably should be. So you're thinking to yourself, well great, now what? I gotta hire a welder, I gotta buy pipe, I gotta learn to weld. Well yeah, you could do any of those things. But I wanted to try something first, see how well this worked. So I picked up a 6 by 24 inch piece of stovepipe and a duck clamp. All I'm going to do is mark and cut a notch in this pipe and slide it right over the existing stack and ratchet it down. Now I will tell you, if you do this at home, be very careful. This pipe is very sharp. Make sure you wear gloves. It's difficult to get together, but once you get it together, it will stay together. Now how do I know that any of this is going to work? Let's fire this baby up and run a few tests. To analyze the results of these tests, I'm using an anerometer to measure the wind speed at the top of the stack. In the cook chamber, I've got 2 probes on either side, plus the analog tell-true in the center raised. This should give us a rough idea of how things change. Theory here with the stack extension on, we should see increased airflow out the stack. The temperatures within the cooker should either even out or the heat should draw more towards the stack. We'll see. Now the first test here is the control. I'm not aiming for a particular temperature, I'm just running the offset. No tuning plates, no stack extension, as is. Once the cooker had settled in, I first tried measuring the airflow at the stack. It started measuring around 1.5 miles an hour, and then I had a hard time getting this thing to read anything. In the chamber though, the temperatures at grate level were 20 degrees apart, with the hot side being at the firebox, and the highest reading of all three being the analog tell-true thermometer. What's happening here is pretty common in most offsets in my opinion, and it reminds me of like a fire in the corner of a room. Yeah, there's radiant heat by the fire, but all the hot air rises to the ceiling, and the coolest part is low and away. Now in an offset, obviously we have an inlet and an outlet, so there's natural draft, and there's some draw here, but it's inadequate, and so is the convection. It is not what we are looking for. Now with the stack extension in place, let the cooker just settle in for a good 15 or 20 minutes. If you're curious, this extension makes the stack now 38 inches tall from the top of the elbow, adding 22 inches to the stock exhaust. Now again, I first tried reading the airflow at the stack, but about this point I realized the heat from the stack had melted the blades of the anerometer, so it was now nothing more than a piece of junk. At the grate level, the temps were again 20 degrees apart, but the hot side was now at the stack, and the tell-true, surprisingly, was measuring nearly in line with the temps at the firebox. And with higher temps, the spread was 30 degrees side to side. So as you can see, there is definitely more draw, and it's not only noticeable by the temps, the stack seems to be flowing with greater force, and the fire is running cleaner, even with the door closed, which is something I haven't done much before. Now, is there too much draw? Honestly, there might not be. What I think is happening here is what's called back pressure. There's so much draw for the heat to be pulled over to this side, it's running into the wall, and it's bouncing back and kind of circulating in this area. That's why we have the higher temps on this side. A lot of Texas offsets, including Aaron's, have a collector on the end to funnel the air into the stack and remove what they call the hot spot off this side of the cooking grate. So if this is the case, I need to add a collector to this thing, and it also means that the airflow and the convection might just be right. But after this I got to thinking, is there a way to possibly even the temperatures without a collector? Well, in his book, Aaron tells you that when the stack is too tall and there's too much draw, you can add a damper to kind of close off and slow that draw, or you can shorten the stack. And when Aaron builds an offset, he likes to build his stack at increments of 6 inches. So what I'm going to do is take this stack, cut off 6 inches, and see where we come out. Once the cooker settled in with a shorter stack extension, the hot sides did swing right to left, firebox to stack, and back and forth. But the temps across the grate level were within 5 degrees of each other, or less. And the tell-true was nearly at or above those marks. So this right here might be the winning ticket. And not only does it perform well, the stack is more proportionate. On Aaron Franklin's offset, his stack is 6 inches shorter than the cook chamber, and this one is just about that. If you're curious, if you had a weld pipe onto your existing stack of your Pecos or Brazos, this is just adding 16 inches from the top of the stack. That's it. And even temperatures. Pretty cool, right? Pretty cool. Now in the end, I really can't say which stack extension height is better. The tallest one does offer a lot more airflow and convection, but then you have the hot spot. The shorter stack extension does really even out the temperatures, and frankly, it was really surprising, and I enjoyed this experiment. There are other variables that come into play, obviously, once I put a 16-pound brisket in here and a water pan, so things may change. But either way, they both definitely improve airflow and convection, and they are far superior to tuning plates, which in my opinion just fake what a properly sized stack can and will do. You still might say, well, you're new at the offset game, you really don't know what you're doing, you haven't cooked on this thing enough, and those are really good arguments. But it's hard to argue with science, right? It's hard to argue with science. It's hard to argue with somebody who's been doing this for longer than most of us, cooking more briskets than probably any of us combined, is making his own offsets of similar size with stacks of this height, and his name is Aaron Franklin. So if you want to argue with Aaron Franklin, you'd be my guest. Well, that's my video. I hope you learned something. I know I certainly did. I do recommend picking up Aaron's book if you get a chance. Please give me a thumbs up if you enjoyed this video. And as always, thanks for watching.